Okay, tune in for me, folks. So what we're going to look at is using this sheet to help us determine what the equation of a graph might be when we're provided either the graph, or sometimes we might not be given the graph, we might just be given a series of points and a little bit of information about dilations, translations, or reflections, or something like that. So when I look at this sheet, our headings across the top are kind of going to be key. What are the different forms that we can write a parabola or a quadratic graph in? What might it look like? Con? So we can have general form. What's general form?
ax squared plus bx plus c.
Ax squared plus bx, that's not an x, bx plus c. Good. What else might it look like? Turning point form. Beautiful. And the third version that's written on the sheet, Toby, thank you for putting your hand up. Factorised form. Now, we haven't spoken a lot about factorised form. So there could be some multiple in the front, and then I'm just going to call this, for the sake of having different letters, I'm going to call that x minus d and x minus e, just because we've already used h, k, a, b and c. All right? So let me actually go through some examples first, and I might help clarify why we might use this. Okay? Let's start with this question. All right, we've got find the equation of the quadratic, the graph of which is shown. And we've got this graph, and we've got a couple of points that are drawn on there. Tell me about that graph. What do you notice? Noah. It's a parabola. What else do you notice about that graph? Toby? Yes, you can go to the toilet, Toby. That's now on the video as well. What else do you notice about the parabola? Con?
It has points of 6, 10.
It's got a point, 6, 10. Good. What else do you notice about the parabola, Austin?
The x-intercept is 5.
It's got an x-axis intercept at 5. What else do you notice about the parabola, Alana? Alana. Thank you, Alana. The y-axis intercept is also, we're going to assume that's at 0, 0. It's very slightly off, but to do this question, we're going to have it at 0, 0. Okay, what else can you tell me about this graph? It's not reflected, so it's not, there hasn't been a reflection, it's not a negative graph, it's not a sad face graph. Perfect. So we actually know a lot about this already. If I was going to choose to work in general form, I know that that a here has to be a positive number. All right. We also know that that a has to be a positive number. We also know that this has to have a positive number because it's not reflected. All right. Now, when I think about the other bits of information I've got, this random point here, it's kind of a little bit random. It's not C. Okay, it's not the y-axis intercept, it's not the turning point, and it's not the axis intercepts. This actually links to the axis intercepts. Remember when we got factorised form, we used that to find the x-axis intercepts. So that 6, 10 doesn't help me at all. Turning point form. Do I know where the vertex is? Do I know where the turning point is?
Yes, you figure that out with symmetry.
I could figure some of it out with symmetry. I could say that the h value would have to be halfway between 5 and 0, which would make it 5 on 2, but I don't know what k is. I could say that c is 0. I could say that d is 0 and e is 5. Once we start putting the information into our equations, which one starts to look like it's building up a little bit better than the others? Factorised form. Because this has allowed me to use the most information. It's allowed me to fill in as many unknowns as I possibly can. And I'm left with just one thing I have to find. Here, I've still got two things I've got to find. It's going to be harder to find two things than one. Here, I've still got two things I have to find. It's going to be harder to find two things than it is to find one. So for that reason, for this question, I won't continue those two methods. I'm going to just work with this. All right? And that's kind of the process of elimination that you would do in your head. You wouldn't write down these three methods in the middle of a test and put in the information into all of them. You'd make some judgments about which process you're going to use. But if you are having trouble, then absolutely write down all three and then choose which one's giving you the most to work with. Question, Con?
It's to do with the factorized form. Would you use the points 6 and 10 up there to substitute into the equation? So you have a y value of 10 and have a...
I'm glad you said that, Con, because this is exactly what we have to do next. At the moment, we've got most of the equation, but we haven't got what A is. So I still have to find out what A is. And the way that I'm going to find out what A is, I'm going to use the other piece of information that I have not used yet. This piece of information, maths usually gives you exactly what you need in order to solve the problem. So here's an example where I've used that to get the start of the problem. Now let's use the third bit of information to get the rest of the problem. What Connor's just said is this point, 6, 10, isn't just a coordinate, it is actually an x value and a y value. So what we're going to do is we're going to substitute this into our rule. So what does that look like? Well, the y value becomes 10. The x value becomes 6. And now the only thing we don't know is A. So I'm going to solve for A. So we're going to say 6 take away 0 is just 6. And then 6 take away 5 is 1. And we've got an A in the front. I wrote that really badly. We've got A times by 6 times by 1. So 6A equals 10. What does A equal? 10 divided by 6, which is the same as? 5 over 3. Can I go any further? No. So here's my final equation. Y equals 5 over 3 times by x minus 0 times by x minus 5. Do I need to write x minus 0?
No, you just write x.
Nah, I'm not. I'm just going to do 5 over 3 x times by x minus 5. Or even better, 5x over 3 times by x minus 5. Or 5x times x minus 5, all divided by 3. They're all the same thing. All of these would get you full marks. All right? They might ask you to write the equation in expanded form, in which case you would just expand that out. I think many of the questions, Toby, you were ahead and did some of these yesterday. I think the questions actually had it in expanded form, didn't they? Yep, cool. They asked for it in general, so you get there and then you expand your brackets. Sweet. So let's have a look at this one then. Same idea, but let's actually work through it. We'll go back to the beginning. What information have I been given about the problem? We've got the x and y intercepts. Okay, so because I know the y-intercept, I can start building this up, and it would be x squared plus bx plus, minus 13. Correct?
Yeah.
Right, what else have we got?
You've got 2x-intercepts, 2, 0 and 6, 0.
Right, so if we're working over here, we could have x minus 2, x minus 6.
You can do the exact same thing, can't you? Substitute.
If we were working over here, we know that h has to be 3. All right, why 3? Oh, not 3, you're right. Why 3? That's a very good question. It's got to be 4, just because I remembered what I was doing incorrectly. Okay, where do you want to keep working from? This one. All right, let's work with this one. We've got the y-intercept. So we now know the point when x is 0, y is negative 13. We're going to substitute this in. So that will become negative 13 equals a times 0 minus 2 times 0 minus 6, which is a times negative 2 times negative 6, which is positive 12a equals negative 13. So a is equal to negative 13 over 12. So here's my rule. Y equals negative 13 over 12, x minus 2, x minus 6. Cool. Third example. Which form do you think I'm going to start with straight away? Vertex form. Why? Because we've got the turning point. I'll do this in a different colour. I'll change to black just so you know it's a different question. This question, we know straight away, has a vertex at 1, 5. So it would be x minus 1, because it's gone one place to the right, squared, plus 5. And we've created a situation where we've got 2 of our values filled in, only 1 left to find. So now, let's use the other bit of information I've got to find the value of a. So the other bit of information is 210. We're going to substitute that in. So we get 10 equals a times 2 minus 1 squared plus 5. A equals 1 squared plus 5 equals 10. So it's just a plus 5 equals 10. A equals 5. Therefore, my rule is y equals 5, x minus 1 squared plus 5. And if you were asked to give your answer in general form, you would then just expand it. Now there's a whole heap of other things that we can do with our calculator and simultaneous equations, but we're not going to bang on about it for too long. I would like you to actually have a practice at just doing some questions where you find the equation now for just about 5 to 7 minutes so that you've had a chance to practice that. And then we're going to do the halfway quiz to set us up for next week and our test that's coming up.
When do you want us to get this into our summary?
Homework. Practice some questions right now, then we'll do the quiz. If you got the quiz done early, then we'll do it for homework. And I'll stop recording so I stop going.